With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
Hello everyone. So the question is, in kinetic theory of gases, which of the following statement regarding elastic collision of the molecules is wrong? Now, from the mechanics, we know that when two bodies strike to each other, then collision is elastic or not. That depend on one factor, and that one factor is basically coefficient of restitution. When two bodies strike to each other, or when two molecules strike to each other, then the collision is elastic or not. That is depend on one factor, and that factor is coefficient of restitution. And coefficient of restitution is basically the ratio of, that is E, and it is basically the ratio of relative velocity after collision and relative velocity of molecules before collision. This is the coefficient of restitution, that is E, that is the ratio of relative velocity after collision and the relative velocity before collision. Now if the value of coefficient of restitution is 1, if E equals to 1, then we can say that my collision is perfectly elastic. When the value of E is 1, that time we can say that my collision is perfectly elastic collision. That means for elastic collision, when the value of E is 1, that means velocity is same before the collision and after the collision. That's why the E comes as 1. That means if E is 1, that simply means that the velocity is same after collision. Okay, when velocity is same after the collision, and we know that kinetic energy is depend on the velocity, because kinetic energy is given by the half mv square. That is means it simply depend on the velocity. When velocity is same, that simply means that kinetic energy is also remains same after collision. Okay, so this is the one thing. Now the other thing is that we know that there is no external force on molecules. Now from KTG we know that there is an assumption. From kinetic theory of gases we know that there is one assumption, and that assumption is that there is no force of attraction between the molecules. From KTG we know, from kinetic theory of gases we know that there is no force of attraction between the molecule. This is the assumption for ideal gases. When there is no force of attraction, that simply means there is no external force on molecules. When there is no external force, then I can say that momentum is conserved. The condition for momentum conservation is that external force will be 0 on the molecules. Now force of attraction is 0 on the molecules from the kinetic theory of gases. That means momentum is conserved. Okay, now the last thing is that when the molecules is collide with the wall of container, that time the per unit area applied force, that the molecules are applied the force on per unit area, and from that concept the pressure comes in concept. From that pressure comes in concept. Pressure comes, temperature comes from that theory, and VRMS is also comes from that theory of kinetic theory of gases. Then when collide with wall of container, when molecules is collide with wall of container, then they applied force per unit area, and from that condition we calculate the force and pressure. Then the temperature also comes, and VRMS speed is also comes in the pressure. That means there is no change in pressure, temperature and VRMS speed. Okay, that means there is no change in pressure, temperature and VRMS speed. Okay, so now check the options. The first option is kinetic energy is lost in collision. That means this is the wrong statement, because now we already discussed that kinetic energy remains constant, remains same before and after collision. That means this is the wrong statement, and this is we have to tell that which statement is wrong. So first statement is wrong. Now the Second statement is kinetic energy remain constant. Yes, this is correct. Momentum is conserved. Yes, conserved. Pressure of the gas remain constant. Yes, remain constant. So first statement is wrong and other three are correct statement. Okay, thank you.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut app today.